Hi, I'm Masato Hagiwara. Today, I would like to present Project MOSLA, recording every moment of second language acquisition. This is a joint work with Joshua Tanner. We were interested in answering those research questions. How do people actually learn a second language? And can we record and document every single moment of this learning process? There have been past studies that attempted to record some aspects of this second language learning process, such as essays and test results. But we were interested in recording not just those linguistic outputs, but also those things such as the interactions between the teacher and the student, and also facial expressions and so on. So that's why we built this MOSLA dataset. We built this dataset by recruiting participants and matched them with their teachers, and each participant learns a language from scratch, from zero, over a course of 2 years. And they do this exclusively through online instruction. And every lesson was recorded by Zoom. So MOSLA dataset is longitudinal, multimodal, multilingual, and control. So it's the first of its kind dataset of this type. So here are some excerpts from the MOSLA dataset.
يعيش في اليابان أولادي في نادي رياضياتي.
¿Tú te llamas Paulino, sí o no?
No.
No.
Hace frío, muy
Sí.
frío.
Sí.
Mucho frío.
Hoy
Pero hay carne, hay verdura, and 你好，
你好，
对，that's
你
it，
好。
你喜欢化学吗？
我非常喜欢化学。
哦，
吃 pizza，非常喜欢吃 pizza。
So here are some more details about the data collection process of the MOSLA dataset. So a learner and the teacher have a Zoom lesson every week for 2 years. The learner is not allowed to learn the language outside these lessons, so the only exposure to the target language is through those Zoom lessons. And every lesson is recorded, including the video, audio, and screen share. So this includes all the learning materials used by the teacher. So in total, we collected 264 videos for 3 languages, and the total duration is 270 hours of the video. And the raw video and audio data are not very useful per se. So we hired bilingual human annotators, and we annotated the part of the data, which is about 3 to 4% of the data set, with utterances, which includes the start and end timestamps of each utterance, and also what language is each utterance, who is the speaker, is it the teacher or the student, and also the transcripts. And for the rest of the data set, we used machine learning algorithms to automatically annotate. Specifically, we used BiAnnote to detect and segment utterances, and we used whisper encoder and classifier for speaker identification, and whisper encoder and decoder for language identification. And finally, we used the whisper ASR model for ASR, automatic speech recognition, to get the transcripts. And this table summarizes the performance metrics of this machine data annotation pipeline. And as you can see, fine-tuning the Whisper models with our human annotation data greatly improved the performance for language identification and ASR. Having this kind of annotation makes it possible to run various kinds of analysis using this data set. And one example is shown here. So first, we focused on some linguistic aspects of the second language learning process. So on this plot, we show the percent of the utterances that are in the target language, which is in the Spanish. In this case, as you can see, as the student gets more proficient, as the lesson number increases, there are more utterances that are in the target language in Spanish, and there's a statistically significant correlation between these two variables. And this is also the case for all three languages for both student and the teacher in our data set. We also looked at lexical complexity. Specifically, we computed this index called Giraud index, which basically captures the lexical diversity or complexity of each lesson. So here, two plot. One is the lexical complexity, the Giraud index of each lesson for the Chinese student, and the other for the Chinese teacher. And as you can see, as the student gets more proficient, as the lesson number increases, there's more lexical complexity. And also you can see that there's a larger slope for the Chinese teacher, meaning that this complexity increase might be a process led by the teacher and the student follows. Another type of analysis that you can do using a data set is multimodal analysis. And we were specifically interested in identifying the areas of the screen where both the teacher and the student focus. And for this, we used a method called the match map method, originally proposed by Haworth and others in 2018. And in this method, given the image and associated audio, we used neural network encoders, pre-trained encoders to get representations per image patch and also per audio frame. And we compute the similarities between those representations. This method has a loss function that increases the similarities between the true image patches and associated audio frames, and also decreases the similarities between false or imposter image patches and audio frames. If you visualize the similarities, you get a heat map shown in these images. This is still very preliminary, but you can see that when the teacher and student having a conversation, it focuses on the face images and the videos, whereas when they are reading out loud some reading materials, it correctly identifies the areas of the screen that both focus on in unsupervised manner. So there's no annotation or supervision involved for this method. So in summary, we built MOSLA dataset, a longitudinal, multimodal, multilingual, and controlled dataset that documents the second language acquisition process over a course of 2 years. And we also added human and machine annotation of utterances, speaker and language IDs, and transcripts. And we also showed some of the analysis that you can do with a data set, which includes the use of the target language and lexical complexity, and also multimodal analysis. The dataset is free for research and non-commercial purposes, and you can access the dataset from this URL. Thank you so much for listening.